Good day, sweet world! We are going to do 16/6 today inverses of matrices. We're taking the determinants that we just learned from last lesson and finding some inverses with it. So we all know what inverse numbers are. An example would be 2/3, and the inverse would be 3/2. The reason they're inverses is because when they multiply together, they come out to 1. So, an inverse matrix is going to be similar to that, but a little bit different. Sorry, I'll stop moving. So an inverse matrix is going to be two matrices whose product is an identity matrix. So we know the identity matrix, right? All the main diagonals are 1, and everything else is 0. Alright, so it's got to be a square matrix. That's a 2x2 one. It could also be 3x3, 4x4, so on and so forth. Alright, so we're just going to be talking about square matrices here because those are the only ones that have a determinant. Now, do all matrices have inverses? Not quite. Right? The ones that don't have inverses are the ones whose determinant is 0. Alright, so as long as the determinant's not 0, it doesn't matter if it's positive or negative, as long as it's not 0, then it will have an inverse. The way you calculate this is a little bit more complicated than what we've already done, but not too bad here. Alright, so we have this matrix A. It's a square matrix. We're just going to start with the 2x2s. Whose elements are A, B, C, and D. Okay, so that in order to calculate the inverse for that, you take 1 over the determinant of that matrix and then multiply it by this matrix that's a little bit twisted around from A. The two things that happen is the main diagonal from top left to bottom right are switched from each other. Okay, so D and A switch positions, and the other diagonal, B and C, stay in the same spot, but they both become negative. Okay, so those are the two things that happen. Here's our quick, easy example. First, with this matrix A, we need to find the determinant. So we got 3, -4, -1, -2. We're going to get -6 minus 4 equals -10. Alright, so the inverse of A is going to be -1/10 times, oh, I don't need that, I need the bracket, times our matrix here, so D, -B, -C, A. So D is -2, -B is 4, 1, and +3. Alright, now the last step here, before you're done, is you have to take your scalar and distribute it in to all of your elements. And that'll give us your final answer here, which is 1/5, -2/5, -1/10, -3/10. So what that means is this inverse of A, if we multiplied it by our original A, you'd get the identity 2x2 matrix. Okay, so the application of this, the reason that this was ever developed, was to solve systems of equations. Okay, so you could transform any system of equations, like this one right here, into a matrix equation, written as AX equals B, where all the variables are here in matrix X, and all the constants are in A and B. So if you ever have a constant times a variable in an equation, how do you get rid of that constant? Well, you usually think of it as dividing it, but what you're actually doing is multiplying by the inverse. So that's exactly what we're going to do. So to solve this, you take matrix X equals the inverse of A times B. Okay, so before we do that, we first have to find the inverse of A. Before we find the inverse of A, we have to find the determinant of A. So we've got 5, -4, 3, -2. Find the determinant of that, we'll have -10 plus 12 equals 2. Okay, so the inverse of A is going to be 1/2 times our matrix here. Remember, we have to switch positions for the main diagonal and change the sign for the other one. So we'll have -2, +4, -3, and 5. Alright, so our inverse matrix here is -1, 2, -3/2, +5/2. So let's solve for our matrix. Our x. Alright, so to get our x's and our y's, we have to do this multiplication. So we've got the inverse of A, -1, 2, -3/2, +5/2, times 1, 2. Now, just to recall how to do matrix multiplication, you can obviously go back to the previous lesson when we talked about it. Or remember that to get the first element in the first row in the first column, you multiply the first row times the first column. And we'll get -1 plus 4 is 3. And to get the second one, second row times first column, and we'll do -3/2 plus 5 is going to give us 7/2. Okay, so what that tells us is, remember, matrix X is xy, so that tells us that x equals 3, y equals 7/2. That's the answer to it. Now, a couple of very quick examples, more examples to make sure that we have a strong base before I let you guys go to work. All right, find the inverse of just this matrix first. Okay, remember, first you got to find the determinant of it. Okay, the way to find the determinant is to do the multiplication, cross multiplication, and subtraction. So we have 27 minus 30 equals -3. Okay, so that tells us, since it's not 0, that we do have an inverse. All right, so we have the inverse of A equals -1/3 times our matrix where we move stuff around, -3, -5, -6, -9. And when we do our scalar multiplication here, we're going to get 1, +5/3, 2, and 3. That is our inverse right there. Okay, let's check out these couple systems before I finish up. So, trying to solve the system, we've got to turn them into a matrix equation. So we need to look like AX equals B. Right? A is going to be all of our numbers here. You got to make sure, obviously, all in the right position. X is first, then Y's. Okay, so we'll have 3, 2, 12, 8 times xy equals 12, -3. Okay, let's find our inverse and get to the other side. So let's start with the determinant. We've got the determinant of 3, 2, 12, 8 equals 24 minus 24 equals 0. Now, that means because our determinant is 0, we can't do it. There's no inverse, okay? So that means we're not going to get an answer. No solution. Okay? That's a nice, easy one. And lastly, this one I think we will have a solution. Alright, we'll do the same idea. Our matrix is going to look like this. Here's our matrix equation. Alright, start with the determinant. Okay, find the determinant of this. This A over here, and we'll have 3 plus 3 equals 6. So the inverse of A is 1/6 times 3, 3, -1, 1. Alright, just do our distribution. We'll have 1/2, 1/2, -1/6, +1/6. Those are really bad fractions, but hopefully you understand it. So finish it off by doing the multiplication. Okay, so in order to solve for x, it's going to be equal to our inverse of A, 1/2, 1/2, -1/6, +1/6, times 1, -11. Alright, we'll do our multiplication here. 1/2 times all these things. So we should have 1/2 minus 11/2. It's going to be -10/2, which is just -5. And 1/6 minus, or -1/6 minus 11/6 should be -12/6, which is -2. And that's the answer. There's your x, there's your y. Alright guys, good luck.